This alarms tutorial will explore the procedures you need to employ to add alarms to your control system. With the developer running and a project open, select the Alarms window in the Project Data section. Here we see a single alarm already set up for us. This was created as a sample alarm to show you how you can set alarms. The source for this alarm is defined as sample. In this case, the sample alarm is looking at 2 digital indications. There is also one analog indication listed, and the 4th row contains one system constant. In the expressions below, the symbol 1 or 2 means that if either of the 2 digital values are high, then the alarm will activate. But if neither of these 2 digital values are high, then the second expression rule is evaluated, and a value comparison exists in this second expression. If the sample analog value is greater than the constant value of 3, then the alarm is also set. Be sure to study the section on expressions within the Help Center documentation. You will need to understand these concepts to be successful. In the meantime, we will show you more alarm examples as we create new alarms in this tutorial. The first thing we are going to do is group our new alarms by sources. The alarms we will create in this video will be either server application alarms or tank level alarms. So let's create some internal sources for these new alarms. Open the Defined I/O Sources window within the Project Data section. Increase the size of this source window so we can all see all of our sources. Here we can see all the sources we created for communications, AB1, MB1, MB2, and GE1. These sources all contain I/O to and from those remote devices. Some of these sources are internal, like System and ComStat. We explored these sources in the HMI Station videos. We can change the description of these sources here if you wish. These descriptions won't be used anywhere else. However, they are helpful here to identify what the sources represent. For our alarms, the first new source will be named SA for server alarms, and the second TA for tank alarms. As we mentioned in the communications video, we like to keep source names short whenever possible. This makes it easier to assign the I/O for each source within our control system. The primary reason we are adding individual sources for these alarms is to more quickly find the alarms when we assign them to graphics or other areas of the developer. Save the changes before continuing. In the alarm window, select the New button. We will select the new source SA for server alarms. Enter the indication name CS01 alarm. The description will read Communications Server 1 offline. Append a new expression and select the source name of System. The indication will be the familiar CS01_OL indication name. Append the expression rule as not 1. This means that if CS01 is not online, then the alarm will be raised. Now save the alarm. Let's clone this alarm and modify it for the logic server application LSO1. Then save the alarm. The cloning technique does make it faster to create alarms because you can use the expression structure of another alarm that matches what you want to create. However, if you have a lot of alarms to create, you might consider exporting the alarms you've created thus far so you can see how the alarms are saved with the export. Then you can modify the alarms within Excel. We will open an example Excel alarm definition spreadsheet to show you how alarms look when exported. You must use this exact format to create new alarms to import. Let's return to the Developer Alarms window and import these alarms. Just note that if you try to import the file while it is still open in Excel, you will get a sharing error. Just close the file in Excel before importing. Now we can see all the new tank alarms we have imported into our control system. The various alarms listed here have expressions that are comparing the different tank levels to their high and low limits. As you can see from the GE1 source, all of these indications are coming from the GE Emerson PLC. If the tank level goes above the high limit alarm is generated. And likewise, if the tank level drops below the low limit alarm is generated. Be sure to observe the 3 different priorities you can set for each alarm. These priorities determine one of the 3 columns where the alarms will appear within your HMI station alarm screen. Finally, at the bottom portion of the alarm window, we have 3 additional options. The first option shows the number of seconds the alarm will delay before becoming active when any expression's rule results to a true state. The second option shows the number of seconds the alarm will stay active after any expression rule results to a false state. And the third option holds the alarm high until the operator on the HMI station acknowledges the alarm. All of these alarms are indications, so in addition to displaying in the HMI station alarm window, you can also use them in your screens to alter the state of your displayed icons. This concludes the tutorial for creating system alarms. Be sure to watch our next tutorial on expressions and calculated values.